As you've heard tonight, plastics are everywhere. The information age depends on plastics for handheld devices. Many new educational tools use plastic-intensive delivery methods, flat-screen TVs, e-book readers, and the tablet you see being used by the young children here. There are still plenty of wires in our wireless world, however. Today's electronic equipment would be nearly impossible to create without plastics and composites. And composites are simply plastics reinforced with fibers. Plastics are used in everything from printed circuit board substrates to wire jacketing to DVDs. But this talk is about plastics on the cutting edge. Futurist Ray Hammond describes 4 great challenges that face humanity. They are greenhouse gases, population growth and mobility, a tight supply-demand balance for fossil fuels, and an aging population. I believe that there are synergies between these global challenges. Some solutions to the greenhouse fossil fuel problem, for example, will also help the greenhouse gas issue. Solutions that address the needs of a growing population will also help us address aging itself. One way to reduce emissions and fossil fuel use is human power. Plastics make this kayak durable, relatively inexpensive, and light enough to carry easily. But it's naive to think that all transportation can be handled by muscle power alone. In much of the world, people use cars for personal transportation. Lightweight plastics, composites, and rubbers make up about 200 pounds of a typical car today. This is expected to increase as fuel economy standards get more stringent, because the weight of plastics is so much, or the density is so much lighter than other materials, and weight is important regardless of the vehicle's power source. Most goods spend some of their time in transit by truck. A study done in Europe on spaghetti showed that spaghetti sauce carried in jars in a truck, the truck carries about 36% glass by weight, but a truck full of sauce packed in plastic carries about 3.6% package by weight. It's not a stretch to say that plastics have been on airplanes since the first plasticized lacquer-coated craft flew at Kitty Hawk. Today's jetliners use increasing amounts of composites because they're stiff and light. Lighter planes carry more payload further, using less fuel. Energy savings is important in buildings and residences as well. A key element of structural glazing like this is silicone adhesives. They're strong enough to bond the glass to the metal structure, but ductile enough to move when the building sways in the wind. In your home, plastics have many energy savings applications, from window frames to weather wrappings. Non-fossil energy generation is also benefiting from plastic materials. Composite blades make fiberglass and polyester plastic are critical elements of today's wind turbines, which are gaining importance for sustainable energy production. Today's solar cells turn more light into power and are less expensive than earlier versions. One of the latest advances is the flexible solar cell. A plastic substrate allows use on curved surfaces, on devices that can be rolled up, and on non-rigid surfaces like this backpack. Bicycling is a healthy transportation that has been made safer through polymer-based brake pads, helmets, grip tape, saddles, and even compression clothing. And if you drop your plastic water bottle, it won't leave broken debris for the person riding behind you to avoid. An obvious aspect of human safety in automobiles is the child safety seat. But plastics are key to other aspects of car safety, including airbag systems, seat belts, high visibility light systems, new technology tires, and especially laminated windshields. Plastic safety equipment is also used in athletics, police, firefighting, military, and factory work. This equipment includes impact-resistant helmets, knee pads, shin guards, fire-protective clothing, face shields, safety glasses, and bullet-resistant vests. As you heard an earlier speaker say, in some parts of the world, 50% of food spoils before it can be eaten. Plastics help to increase shelf life, tamper resistance, and stability of food. Examples include clear plastic wrap for meats and cheeses, aseptic juice boxes, and PET bottles. Food production is another area that benefits from plastics. New agricultural equipment is lighter and more fuel efficient than the use of plastic or composite body panels. New photoselective films are being used in greenhouses to filter out specific wavelengths of sunlight and optimize crop yields. In some parts of the world, water is in short supply. Drip irrigation delivered by plastic pipe and nozzles reduces evaporation and ensures that water is placed where it is needed. Plastic membranes are key to desalination systems that turn salt water into drinking water. An early sign of aging is the need for reading glasses. Today, most glasses and contact lenses are made from polymers. The sliding surfaces of replacement joints are also plastic, and research is underway to make composite joints that more closely match the stiffness of natural bone and reduce the need to replace joints. Plastics play an important role in today's medical equipment, helping detect and treat illness with greater success. Plastics also help ensure that medical instruments and supplies remain sterile prior to use. The future may see replacement muscle, organs, and even blood based on plastics. So as we have seen, plastics are being used to address some of the world's greatest challenges. To me, the question is not what plastics can do for people, what people can do because of plastics. I'd like to thank Peggy Malnati and Wim DeVos for their contributions to this presentation.